5, Lesson 8, Rational Equations, Part 2. In this lesson, we will solve rational equations which reduce to quadratic equations. So also consider equations have no solutions. Recall the following strategies when solving rational equations algebraically. If the equation consists of a single rational expression on each side, we use cross multiplication. So that's when you have fraction equals fraction. Just cross multiply, get rid of the fractions. Okay, that's what that's telling you. Okay. If the rational equation has more than one term on either side, consider multiplying each term by the lowest common multiple. So that's where if it's over x for a couple things, we're going to times everything by x to get rid of the x in the bottom. So again, the idea is, and just to summarize, 1 and 2, we're trying to get rid of the fractions. We don't like the fractions, so that's how we get rid of them. Okay, you can cross multiply, or you can multiply by the least common multiple, and then you just use your previous skills for solving. So that's your quadratic solving, or that's your linear solving. Linear is the easy one, quadratic's a little bit harder, but that's unit 3. And then we always need to check for our non-permissibles and our answers to make sure that they work. Okay, so let's go through these here. So it says, in the previous lesson, we solved the equation of 3 over x plus 1 plus 1 over x minus 1 equals 2 graphically. The solution was, what was the solution on that? Do you guys remember? 0 and 2. Yep, 0 and 2. Good memory. Good job. Okay, so 0 and 2. Okay, now we're going to solve it algebraically. Okay, so we know it's 0 and 2, so we know the answer, and we're trying to get to it. Okay, that reminds me, I have to ask you a question after this too. Okay, so what we have to do is again, your first focus is how can I get rid of the fractions? Is this a cross multiply example? No, it's not fraction equals fraction. So we want to do the least common multiple. Okay, and so what you're going to do is, see how it's x plus 1 and x minus 1? We're going to times that to both of them. Like that. Right there, and then right here. I know I'm fitting it in here. Like that. And so the reason that's important is because you can do whatever you want to an equation as long as you do it to everything. So we're multiplying the entire equation by x plus 1, x minus 1. Now on the left side, some things are going to get like a little bit easier for us, because this will cancel, and this will cancel. Now people say, well, wait, you just multiplied to get that. No, I multiplied actually to cancel that to get rid of the fractions. Yeah. Not under the 3, no, because we just, that's what I'm saying. We're multiplying the entire thing by a number, so it's okay. The bottom would just be gone. Right. Essentially, yeah, in a way. Yeah. If you want to think about it that way, that's fine. No. So what we have left is, okay, and I'll write this one more time and try to explain to make sure those of you guys that look a little lost right now can get some more understanding, okay? So here's what we're doing. Again, this is where I'm at now. So I went from fraction to no fraction, so that's the point. So what we've done is we've taken, so just in general, guys, if I want to multiply this equation, everything by 4, I could. I can hit everything with a 4, and that's fine, because it's balanced. I'm doing it to every single term on both sides. But this is the same thing. I'm multiplying everything by x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. And by doing that, they're on top. Okay? This one doesn't have a bottom, but that's fine. So I can cancel the x plus 1s, which is why we did this, so we could have no fractions. And then what Nolan's kind of saying for the left side, you can kind of see it's a little bit of a cross multiplication, right? Because the x plus 1 went here, the x minus 1 went here. That's fine, because their factors canceled like that. That's fine if you think about that. Just make sure that you have both of these in place on the right side. Yeah, Kale?
So since the denominator went for the 3 over x plus 1, the x plus 1 is just cancelled, so we get x minus 1.
Right. Yeah. Yeah, so the x plus 1 is canceled. And then again, Kale, that's why we multiplied by these two factors, to get them to cancel one of them. Okay? So here we are. We're right here. So we're going to distribute. We got 3x minus 3. Whoa, minus 3. We got plus x plus 1. So the left side is going to be 2x minus 2. I'm going to fully simplify the left side. So are we okay with that? Yep, 4x. So you're not okay with that. That's good. 3 plus 1. Thank you. All right, 4x. Thank you. The right side, when we do FOIL out x plus 1, x minus 1, that will be x squared minus 1, right? And then we're going to distribute the 2 to that. So it's 2x squared minus 2. So this is where we're at. So you have a square that's not going to cancel, so you're going to have to use the solving by factoring or solving using your quadratic methods, okay? So unit 3 stuff, a little bit of unit 2. And so what I like to do is the 2x squared is the important piece to me, so I'm going to keep that there because it's positive. I'm going to subtract this stuff over and add the 2 over. And you see the 2's cancel, so that's good because it's going to be pretty easy to factor then. Because I can pull a what out? And 2x. And that leaves me with x minus 2. And now you see your solutions of 0 and 2. Okay, so take a look at that, ask some questions. I'll pause the video. Okay, so the answer is 0, 2. We can plug 0, 2 back into the original and make sure it's true. If you do that, it will work for this one. We kind of already knew that because we already got this answer before. So we'll work on verifying on the next section. Okay, so let's go into the next page here, try the next example. All right, so next example. So it says, consider a rational equation x squared minus 5x minus 6 over x plus 1 equals 2. Okay, so we are solving the rational equation by cross multiplication. Well, how is that possible? We don't have fraction equals fraction. Well, we can change it though, right? To 2 over 1, and now we can cross multiply. But in reality, you're not really cross multiplying, you're just kind of multiplying the x plus 1 over. But I mean, if you want to call it cross, that's fine. But what happens is the 1 hits this, so that stays the same. The x plus 1 hits the 2, so it's 2 times x plus 1. And now we're working on solving. Just a 5 here. So then we distribute. We have 2x plus 2, and we're going to move that over to this side. And that's where we're at. Okay, so what do we do from here? Factor it. And what does that factor to? X plus 1, x minus 8. So it'd be negative 1 and 8. Okay, but we need to check, though, and see if that works. So if I go to plug 1 in, what happens? Or negative 1 in, what happens? Yeah, it gets me 0 on the bottom. That's a non-permissible, not allowed. So this one's no good. Okay. If I plug the 8 in, I'm fine. It does equal 2. Okay, so 8 does work. So to explain why one of the solutions to the quadratic form does not satisfy the original equation, it is a non-permissible. Okay. If you do plug it all the way in, you get a negative. You get a 0 over a 0, and 0 over 0 is actually undefined, but it still doesn't equal 2. So you know it doesn't work that way. Yeah. Factor the top out. So the top factor would be, right? Nope. Oh no, you're right. So you're factoring the top. But remember, so he's making a great point here. He sees the x plus 1 is here. That's great. However, when you simplify and cancel, is negative 1 a non-permissible still? It still is. Okay, so even though you're right, Gavin, this does simplify and gets rid of that. That's still a non-permissible, so we still reject it. Okay, but that good eye there, good eye. Okay, any questions? Okay, I like the side chatter in your new groups, guys. That's what I want you to talk about what we're saying up here. If you need clarification, turn to your partner if you need to. Okay. All right, so number 3. State the non-permissible values. Solve the equation algebraically and verify the solutions. Okay, so A, what's a strategy we're going to use for A? Yep. All of you guys are saying it. Times everything by x. When you look at that, there's one fraction, right? And that fraction's over x. So we're going to multiply everything by x to get rid of that fraction. Does that make sense? So I'm going to go x, x, x. And so this x just cancels, so that's just a 2. X times x, so x squared plus 2 equals 3x. And so now we're kind of to a comfortable spot. We're solving a quadratic now. So I'll wait, let you guys get what happened there. So we're just going to solve. We're going to minus the 3x over, so it's equal to 0. It's a quadratic. So it's going to be x squared minus 3x plus 2 equals 0. That does factor to that. Okay, so my solutions are 1 and 2. Plug it back in and just make sure they work. So let me erase this up top here so we can kind of see. So I plug this in, we can just kind of do it out loud. You can write it out if you want, but if I plug the 1 in, 1 plus 2 over 1 is what? 2. 1 plus 2 is 3, so 1 works. 2 plus, what's 2 over 2? 1, so 2 plus 1 is also 3. They both verify. Right, so x can't be 0, yep. So non-permissible x can't be 0, and we're okay. We didn't get that for a solution. Okay, perfect. Yeah, quadratic formula, yep. Quadratic formula is what you have to do. You can also use your calculator and find the zeros, so if you don't remember the quadratic formula. There's a lot of the ways, but yes. Good point, Joel. Don't forget, not everything in life factors. Okay, so if it doesn't factor, your next thing is quadratic formula or using the zeros in your calculator. It is possible that it doesn't have any zeros. It just means no solution. Okay, no solution could be possible as well. Okay, so this one here, so we're going to cross multiply, right? Fraction equals fraction. Okay, so I'm going to go x times x plus 2 equals 2 times x squared minus 4. Okay, so there's a couple of things you could do here, but I'm just going to go ahead and distribute and simplify. It'll work out just fine that way. Yeah, well, because this has an x plus 2 in it, so they both have an x plus 2. I could drop that, but I don't. Yeah, you can. I'm just not going to do that. If you guys want to, you're fine. I'm just going to try to keep it simple. Okay, so x times x is x squared plus 2x equals 2x squared minus 8. And now I'm going to move stuff to the right to keep a positive x squared. So we're minusing x squared. We're minusing 2x. So I get 0 equals x squared, because I minus an x squared, minus 2x, and then minus 8. So my factors are x minus 4, x plus 2. So I get 4 and negative 2. Okay, but what happens there? Yeah, we're going to reject the 2, right? Because negative 2 is a non-permissible from here and here. My non-permissibles are, by the way, plus or minus 2. A negative 2 here, and then a plus or minus 2 here makes that 0. So this guy is rejected. So 4 is all it works. So you can plug 4 in to make sure. If you plug it in, let's just do a mental math here. 4 on top. 4 squared 16 minus 4 is 12, so that is 1/3. 2 over 4 plus 2 is 2 over 6. 2 over 6 is also 1/3. So they are good for number 4. Right. So you got rid of your non-permissible. Okay. Okay. So last one here. Just a little bit of a tough one. Okay, so what do we want to do with this one? X minus 3 goes to everything. Yep. So we're going to go x minus 3 here. No, you don't have to FOIL, right? X minus 3 on the 4. And then x minus 3 here. No, you don't have to FOIL. Okay. So it says show that this has no solution. So we're going to solve this, and we're going to get no solution, they're saying. So this cancels. This cancels. I'm left with 8x plus 10. Distribute the negative 4. Minus 4x plus 12. That's what the negative 4 distributed in is, because negative 4 times negative 3, positive 12, equals 10x plus 4. And now we're just solving. This is linear. There's no squares, so we're just solving. So 8 minus 4, I got 4. 10 plus 12, I got 22. Minus 4x. Okay. So what happens is we're going to get 18 equals 6x. Divide 6, so we get x equals 3. X equals 3 is what? A non-permissible, so it's a problem. Okay, because we know that x can't be 3. Okay, so that's not allowed. Okay, so this answer, since that's my only solution, has no solutions. And all that means is, if we're being straightforward, guys, if you graph this in your calculator, those graphs wouldn't cross. That's all it means. Okay, so that's what will be, that's where it is. So this would be a simply no solution answer. Okay, all right, so stop there.